Hello and welcome to this Tungsten Operator Masterclass training where we take a look at some of the advanced configurations. And my name is Chris Parker, VP of Customer Success here at Continuant. So in this short course, we're going to review the various YAML customizations that you can make when you build your Tungsten cluster with the operator. We'll look at how to configure backups, initiate restores, and also how to import data at the initial creation stage. So YAML customizations. In the previous sessions for the Operator Masterclass, we looked at how to deploy Tungsten Operator and then how to deploy a cluster within the operator using YAML files to define the cluster. In the previous sessions, we just looked at the basic samples, so not really making any customization, but just deploying a cluster using the sample files that we provide to get you started, either a standard 3-node configuration, composite active-active, or composite active-passive clusters. So in this session, we're just going to look at some of the YAML files in a bit more detail on some of the options you can tweak and change to change the way that your cluster is configured. So we're going to look at the monitoring, how to adjust the topology type, configuration of the connectors, pod configuration, adjusting storage, and also custom INI settings. The custom INI settings we did actually cover in the previous session, but I'm going to cover it again in this session. So first of all, enable or disabling monitoring. Very, very simple and straightforward. This enables or disables the Prometheus exporters. So within the YAML configuration, you have a section with monitoring, and then the value is enabled either true or false. Literally, all you need to do is set that however you wish. And then when you deploy your cluster, the Prometheus exporters will be enabled for your monitoring. Topology types. There are 3 topology types. There is clustered, composite active-passive, and composite active-active. The first example at the top there shows you a simple clustered topology. So the service name, alpha, topology is clustered, size 3. So that's the number of nodes that will be created. Point of note, the number of nodes must be an odd number for quorum, obviously. So 3, 5, 7, 9, etc. The default minimum would be 3. If you wish to deploy a composite active-active or active-passive cluster, you use the same cluster topology, but you group that within the relevant topology here in this example. So we have the data services, the name of global, which is the main global composite cluster. Topology is active-passive, and then its sources, it is made up of 2 other clusters that we're going to create called east and west. So that's the sources for the global composite. You then define those individual east and west clusters. So you have the name of east. The topology of that is a cluster topology, 3 nodes. And then we have west, which is also a cluster topology. The source of west is east and the size 3 nodes. What this means in the active-passive scenario is that the east cluster will become the active cluster. The west cluster will become the passive cluster using east as its source of data. If you had multiple clusters here, then this is how you link those clusters together. In an active-active topology, I don't have an example here. The only difference is your topology would be composite active-active, not composite active-passive, and you wouldn't use the sources reference within the west cluster that I have here. So you would simply just have east clustered, size of 3, and then you have the west clustered with a size of 3, and then both of those clusters would be active. Next, the connectors. So you can define the number of connectors and the resource limits for those connectors, so CPU, memory, etc. The replicas entry under the connector here will determine the number of connectors per cluster. So within a single standalone cluster, you would get 2 connectors in this example. If you had defined your topology as composite active-active or composite active-passive, and you had defined 2 clusters, then the number of replicas would be 2 times the number of clusters. So in this example, if the example you see on the screen was for a composite active-active cluster, you would have 2 connectors per cluster, resulting in a total of 4 connectors. Pod configuration. So this is where you can specify the limits for the individual pods for MySQL, the Tungsten Manager, and the Tungsten Replicator. In this example here, the names, so you see name MySQL, name Manager, and name Replicator. Those names must not be changed. You leave them as they are. The values here that you can change are things like the CPU and the memory. In most cases, the limits you see here are sufficient, but the ones that you probably want to focus more on are the MySQL limits. Obviously, this needs to be adjusted based on the workload that you anticipate or that you have in your MySQL database. That is only something that you would know. So when you're configuring this, obviously set those limits accordingly. Storage. So this is where you configure the storage for the MySQL database, THL files, and what you would do here is obviously just specify the values against the storage line. So the example here for MySQL data has 40 gig, and then you have the metadata for THL, which is 20 gig. So yeah, only change those values in that case. I covered this in the previous training session, and I'm going to cover it here again. If you are familiar with tungsten clustering and you want to set custom INI properties, there's hundreds of different INI properties that you can set. You can specify them here in the configuration block in the custom tungsten INI properties block, as you see on this example here. If you want to set properties within the defaults stanza, if you're familiar with how a tungsten INI file looks, we have the default stanza. So for those, you would include the custom INI properties as you see in the top spec. So you have configuration, custom tungsten INI properties, and we have connected bridge mode true, REPL buffer size 10. So those values would sit within the defaults stanza within the INI when it's built. And then if you want to specify properties that are specific to a cluster, then within your cluster topology section, we looked at this on the previous slide, name, east, topology clustered, 3 nodes. In there, you can add in custom tungsten INI properties, and the values there would be specific only to the east cluster. Obviously, review the tungsten clustering documentation if you want to see a full list of all the possible INI settings that you have available. Okay, on to backups. So you have 2 custom resources, tungsten backup, which represents the single backup, source cluster, status, size, etc. And then we have the actual backup configuration itself, the policy, the storage destination, and then the backend configuration. At the moment, our clone is the only supported backend configuration. Do keep checking the documentation. If that changes, then that will be updated as we go. And obviously here we have an example of that backup configuration. So we have the YAML file here. These YAML files are provided as samples within the Tungsten Operator packages. If you've downloaded the software, extract the software and you'll see that samples directory with all of these examples in here. We have all of these examples on our documentation pages as well, so you can use those side by side and refer to what we're talking about here. In this example, we have the backup configuration sample, which is our name, and then we have the spec for that. So we have the type, which is our clone, MySQL dump, the destination bucket, directory, and then various flags, purge remote backup on deletion, overwrite existing resources, etc. And then you have the destinations and all of those various credentials required for the storage of those backups. Scheduling the backup is defined within the MySQL cluster resource. You specify the custom password, and then you have the backup configuration, the schedule, which is in cron format. So the example here, and then the retention can also be specified. So keep 5. So it will obviously rotate those backups. What's important here is in configuration ref, we have name, tungsten backup configuration sample. If I switch back to my previous slide, it is the same name that you specify in your backup configuration here. So it's important that these 2 values match so that the scheduling can schedule the correct backup configuration. Once all of that's set up, you can view the Tungsten Backup Resource status fields, which will show pending, processing, succeeded or failed, so you can get a feel of the progress of your backup. In terms of restoring your backup, there are 2 approaches. You can either create a new cluster and initialize it with one of those backups, or you can use kubectl to reset it. So how do you create a new cluster and initialize it with a specific backup? Well, first of all, you use the kubectl tungsten backup list to get a list of what backups you have available. And then you create within one of your YAML files, you have an init block. And within the init block, you say from backup, and you put in the name of the backup that you retrieved from the kubectl list. One thing here is the configuration ref, backup configuration sample. Again, this needs to match the name that was in your backup configuration YAML. I'm not going to go back 2 slides to show you, but here's an example here. If you remember, we had that initial backup configuration where we defined the duration of the backup, and we have the name there. So those names need to flow through and need to be the same for everything to work together. And then you use the kubectl apply commands to apply these YAML files that will build that new cluster, but it will source that backup and build that cluster from the backup that you took. The other option is using kubectl and resetting a cluster. There are 2 options. You can just do a basic reset as shown here, and that will use the latest backup available, or use the tungsten backup list option with kubectl to get a list of the backups, and then choose the backup that you want, and then pass that into the kubectl reset and reset using a specific backup name. Finally, how do you create a cluster and seed it with data? So there are 2 ways you can do this. You can either import SQL or import using a URL. So first of all, you would configure your init script, and we have examples of these again. The example in the package that you would download is called the MySQL init script, and we have that here at the bottom. So the sample within it, again, the secrets file from volume, ConfigMap, MySQL init script. So here we'd specify the initialization for this cluster is based on the contents of this script, and then you have the rest of the YAML configuration at the bottom there. What you would then do is you would do kubectl apply that init script, so that will configure that bit of it, and then you would do the apply for the actual cluster within it, which then uses that init script to build the cluster. So in terms of using the SQL in your init script, you have data, input.sql, and then all of your SQL listed here. Obviously, if you have lots and lots of SQL, that could be quite unwieldy and not particularly efficient or a great way of doing it. So instead, you can have your SQL in a file at an accessible URL. And then in the second example, you would use that URL in the from external artifact tag, and it would load the MySQL database using that sample file. Okay, so what do we do in this course? We reviewed all the various different YAML customizations that you can make, which will then obviously define the end Tungsten cluster that you have running within the operator. We learned how to configure backups, initiate restores, and also how to import data when you want to initially seed your cluster with some data, be it from pure SQL that you put in the file or from an external file. I hope you found this session useful. Reviewing this session along with the previous sessions should now give you enough background to start using Tungsten Operator. As always, if you have any questions, please do reach out to us via our usual support channels. And please do keep checking our online documentation and blog posts. Tungsten Operator is a new product for Continuant from version 8. New releases will be coming out all the time. Documentation will be getting updated, new features added. So do keep an eye on those blog posts and doc pages to get all of the latest up-to-date information. Thank you for your time. Goodbye.